I would like to welcome everyone to the product release webinar for the SmartCode Qualified C libraries. My name is Roger Smith. I am responsible for technical marketing at Tasking and will be the presenter for today's webinar. This webinar will be recorded and available on the Tasking website at the link shown below. In case any questions arise during the webinar, we invite you to use the Q&A function on your Zoom console. All questions will be answered at the completion of the webinar. Tasking is a leading provider of development tools headquartered in Munich, Germany, offering high performance, high quality, safety and security-oriented embedded software development tools for multi-core architectures. Earlier this year, Tasking announced the acquisition of LDRA. With the acquisition of LDRA, Tasking further expands its capability to provide a complete embedded software development workflow, which includes requirements traceability, static and dynamic analysis, compile, debug, test, and reporting solutions. The Tasking development workflow provides a complete safety solution that covers the entire embedded software development process, from source code to high-performing, technically accurate, functionally safe, and security-compliant software. Tasking offers ASPICE Level 2 compliant certified toolsets for many architectures, including Tri-Core, ARM Cortex-M, Cortex-R, and RISC-V SoCs. Tasking's family of IC7 Blue Box hardware debuggers establishes the debug and trace connection, and WinIDEA provides a versatile and powerful embedded software IDE. The Tasking safety and security ecosystem includes safety tools designed to ease the compliance with industry-relevant safety standards and requirements. Tasking's performance tools provide fast and efficient access to flow tracing information to resolve stalls, cache misses, and optimize the core load in your multi-core system. Finally, Tasking's development support tools provide accurate solutions for your complex mathematical operations, as well as hardware configuration and RX port mapping for your PCB development. The addition of LDRA's embedded software solutions provide the capability to simplify your software testing and validation needs. Please continue to refer to the LDRA website for more information on the LDRA product and capability offerings. Our webinar today will focus on Tasking's commitment to safety and security and how it enables our customers to design and implement RxTC4X safety-compliant embedded software with the SmartCode Qualified C library. My name is Roger Smith. I'm a Senior Technical Marketing Manager at Tasking. I'm an electrical engineer with over 25 years of experience in the automotive industry. Before Tasking, I spent 12 years as an application engineer supporting braking, electrical power steering, passive safety, and ADAS applications for a global leader in automotive semiconductors. As the Senior Technical Marketing Manager for Tasking, I support a wide range of multi-core embedded software development tools. Before I begin today, I would like to wish all of our attendees a good morning, a good afternoon, or a good evening. Looking at today's automobile, we see that automotive electronics has evolved into a network of interconnected ECUs, performing advanced algorithms relying on multi-core microcontrollers, data sharing, and high-speed communication. These advancements have led to the most basic functions having an automotive safety integrity level rating. Since we're talking about ASIL D software development, let's look at the braking module. The braking module has several inputs like wheel speed sensors, lateral and longitudinal accelerometers, yaw rate sensors, etc. All of these sensors have complex transfer functions and require ASIL D certified math functions to resolve the correct vehicle state, which are needed for safe control of the braking system. From skyscrapers to bridges, the strength of any structure lies in its foundation. Tasking has adopted a similar methodology in the design and implementation of their safety and security compliant embedded software tools. The tasking safety ecosystem consists of our 6 pillars of success. Process compliance ensures tasking products are developed with stable and safety-related processes like ASIL CL2, helping us to deliver best-in-class products. Certified compilers ensure our toolsets are certified for conformance to functional safety standards. Qualified C libraries ease the development of safety-relevant embedded software with ASIL D certified libraries. Integrated static analysis tools like MISRA-C and CERT-C mean our customers don't have to purchase third-party tools to ensure they're following safe and secure coding guidelines with their safety application. Debug and verification tools provide the capability to connect to the target and debug, analyze, trace, and verify their application operation. And finally, errata management tools help to ease compliance with safety standards like ISO 26262. When talking about ISO 26262, the toolset and all the related components need to be qualified for the purpose of functional safety software development. So for an ASIL D system, this means the developer must ensure that system failures do not lead to any external conditions which could cause harm to people in the vehicle or outside of the vehicle, at least in terms of the automotive industry. ISO 26262 conformance also requires both the qualification of software tools and software components. So for a compiler toolset like SmartCode, this means that both the compiler executable and its associated libraries must be qualified. ISO 26262 views the qualification of tools and software components as independent topics. If we shift our focus now to the ISO C standard, the ISO C standard is the basis for the implementation of the compiler toolset. This specifies things like the startup code, syntax, constraints, and the semantics of the C language, which are the basis of the compiler and its runtime libraries. These library facilities, like what's inside header files and how the C library function should behave, are all described in the ISO C standard. When examining this ISO C standard, you'll see there are many forward and backward references between the chapters in the actual standard. Thus, the startup code, the compiler executable, the runtime libraries, header files, etc., are not isolated components, and in the view of the ISO C standard, cannot be qualified in isolation. So ISO 26262 views them as separate and must be qualified as separate, whereas ISO C, again, now views the compiler and associated libraries as one integrated system. This is the first problem that we have to overcome. We will get to that in a little bit. First of all, let's look at the software tool qualification basics. So there's 4 basic qualification methods. The first 2, increased confidence and evaluation of the development process, are for lower ASIL levels like B and lower. We're primarily focused on ASIL D, so we're going to focus on either the validation of the software tool or development in accordance with a safety standard. The other thing that's important when doing the software tool qualification are the terms certified versus certifiable. And these terms have different meanings depending on what industry you're talking about. Specifically in the automotive industry, which has a lot of ASIL D safety requirement software development, certifiable does not mean certified. So certified, that means the tool manufacturer has performance to qualification activities. You can see our software engineer here is using certified tools. He has nothing to worry about other than developing the software. Certifiable, however, means that the tool user must perform all of the qualification activities. There's a lot of hidden costs built into here, and you can see our software developer here not having the greatest night. So let's look a little bit more into some of the software tool qualification details. So ISO 26262 offers 2 alternatives for qualifying your toolset components, which consists of like a library, for example. There's the commercial off the shelf, or the COTS method. And in this method, typically the parties that are doing the qualification are not the same people that developed the software component, which is a very important distinction, as we'll see in the next couple slides. Then there's the safety element out of context approach, which means that the software component must be developed in accordance with the ISO 26262 lifecycle, and that all the assumptions of the use of that component must be built into the design and implementation of that component. So let's take a little bit deeper look here into the COTS qualification method. So in order to perform the qualification of any software tool, the software requirements must be available. In the terms of the compiler, which we're talking about, this includes the requirements must be available for both the compiler executable and its associated libraries. There must also be information available on the requirements for runtime for the runtime environment, as well as the numerical accuracy of the mathematical algorithms. Herein lies the problem, since a toolset's user guide doesn't provide such details. The other thing when we're using the COTS method here is we need to understand the MCDC approach. If you're not familiar with MCDC, this stands for the Modified Condition or Decision Coverage, and this is a software testing criterion that ensures that each condition within a decision statement independently influences the decision's outcome. And what we can see in order to do this, that you must have a verification test set, which depends on the software design and implementation. Here lies our second problem. If we have a case statement with 10 different possible outcomes, now each one of those outcomes must independently influence the decision's outcome. If you don't have access to the source code because you didn't write the actual compiler, you don't have this information. So how do you adequately test to make sure that each one of these outcomes is a possible solution? One of the caveats of using the COTS method is that the software must remain unmodified, and that any issues found during the qualification cannot be fixed, but must be solved using a workaround. So clearly, in terms of compilers and software development tools, this qualification method is unattractive from a functional safety perspective. Let's look a little bit more into the safety element out of context method. And for this process, all ISO 26262 safety lifecycle steps that are relevant must be part of the qualification. So this means that you must have a suitable development process. You must develop technical safety concepts, which are based on the assumptions of the software component usage. You must have architectural design. You must address the functional aspects of the component. You must design, implement, and verify the software units, and define the software integration procedure. This process is much more elaborate than the previously discussed COTS-based approach. One of the advantages of this approach here is that the software component can be used without any requalification effort. And the safety documentation contains the assumptions on safe usage and provides guidance on how to establish the validity of those assumptions during the integration of the library. So now let's look at the tasking approach. So based on the conflicting views earlier described with ISO 26262 and ISO C on compiler and the associated libraries, the different methods for tool qualification and software component qualification, the benefits of using certified versus certifiable, the fact that with 26262, a component that is qualified with the COTS method can't be modified, and based on the fact that the conformity assessment bodies such as the TÜV state that the tool supplier can perform a good library qualification based on having access to the requirements and test sets, tasking is chosen to implement RC libraries with the safety element out of context method. So if we do a qualification summary here before we dive into an actual use case, both a compiler tool and its libraries must be qualified. The manufacturer is in the best position to do the qualification. The user's task can be limited to applying the provided safety guidance in the safety manual. Numerous benefits like cost efficiency, compliance, risk reduction, and performance. And all of this allows you, the end user, to enable on focusing innovative and differentiating your products without jeopardizing the functional safety compliance. So let's look at a common automotive use case. So we're going to look at engine control. This is a ASIL C or D type application. And in this particular example, we're going to base it on the Infineon RX TC4X. So we can see here the accelerator or the pedal travel sensor, and then we can see it both, we can see this exponential function here in the transfer function. So in order to determine the required torque or engine vehicle speed, we're going to need to use either the exponential function, the natural log function, or a log function. Since this is an ASIL D application, therefore, these ISO C math functions must also be ASIL D certified. When we look at our customer requirements here, from the previous slides here, we know for doing ASIL D software development that the tool set must be certified for developing ASIL D software. We know that the vehicle speed output must have a high degree of numerical accuracy, and we know that any library functions that are used in the application must be qualified for ASIL C or ASIL D. So we're doing development here on the Infineon RX TC4X. And so we're going to be, in this use case here, we're using the tasking SmartCode compiler toolset, version 10.3R1. So you open up the box, what do you get? So you're going to get a compiler, assembler, and linker and locator, which has been certified by the TÜV Nord for use in ASIL D software development. You're going to get the integrated runtime and floating point libraries, also qualified for ASIL D. Since they're integrated with the compiler, they're basically certified with the compiler. We're going to get a C library, ISO C library, which has been qualified for QM. If you're not familiar with QM, QM is a automotive safety integrity level rating, and quality management represents hazards that do not have safety requirements. That's a very important distinction here. What comes with this QMC lib? We're going to get the startup code, the trap handlers, and these library functions. So our compiler, assembler, and linker and locator are all qualified for ASIL D. Our runtime and floating point libraries are qualified for ASIL D. However, we have a problem here doing ASIL D software development because our library, or our C library, is only qualified for QM software development. If we take a step back now and look at our checklist here, we're developing ASIL D software. The first three here are provided with SmartCode, version 10.3R1. But this C library that's qualified for ASIL D with the documentation, that's going to come from the purchase of the SmartCode qualified C library, which is the focus of today's webinar. One of the key conclusions here is that, the C library that is shipped with the qualified or certified SmartCode compiler toolchain is not suited for development of functional safety related software without the purchase here of this qualified C library. So what are these qualified C libraries? So they're functionally safe and they're qualified for ASIL D software development. As discussed earlier, they're developed as a safety element out of context. And the state-of-the-art algorithms that were used in designing these QC libs have resulted in reduced memory footprints, reduced execution times, and high numerical accuracy for most of the functions. This library, the qualified C library, contains the startup code and trap handlers. About 200 functions have been qualified for ASIL D use. The remaining functions are qualified for QM use. And the safety manual is provided, which comes with application notes and details on how the qualified C library should be used in the context of safety development. One of the main takeaways that I want you to take from today's webinar is that functionally safe software requires both a qualified compiler and a qualified C library. So what are the benefits of the qualified C libraries? They reduce the cost of software development, qualification, and certification activities. helps to assure compliance with functional safety standards and regulations, reduces risk, makes it more reliable, very excellent accuracy of math functions. And here you can see in this table here, we examine some of the functions, some of the math functions available within the ISO library. And we show here, looking at code size, you can see a large percentage, if not all, of the actual code size is smaller based on these advanced algorithms that were used. You can see the cycle counts here are lower, the instructions are lower, and most importantly, you can see that the QClib accuracy here is a lot more accurate than the QM than the accuracy of the QM functions. So how do you use the qualified C library? So again, we open up our tasking SmartCode toolbox, and what do we have? We have a compiler, an assembler, a linker, the floating point and runtime libraries, and this QMC library. So in order to use it, it's basically a two-step process. The first thing we're going to do is we're going to replace the QMC library with the qualified C library. The next step is we're going to apply guidance from the safety manual. Now, the safety manual is provided in two formats, both a human readable format and a machine readable format. The advantage of the machine readable format is that it allows interoperability with requirements from your requirements management system. And the safety manual provides formal evidence for the correct integration of the library into your application. One of the other key points here to remember is that the qualified C library is qualified for use with a specific version of the tasking compiler toolset. So let's look at what the available qualified C libraries are. So you can see we have a tri-core qualified C library for the Infineon RX TC2 and TC3 devices. This qualified C library has been qualified with the VX toolset for tri-core version 6.3R1. You can also see here that we're now, as of today, releasing a SmartCode qualified C library, which is for the Infineon RX TC4 device. It is qualified or certified with the SmartCode version 10.3R1. You can see here with the SmartCode qualified C library, we have added support for ISO C17. There is a distinction here in the library archives. So for the SmartCode qualified C library, there are two archives. There's one archive for those 200 ASIL D functions, and then there's a separate archive for the QM functions. And this provides the advantage of not having to scan the map file to ensure that no QM functions were inadvertently or accidentally linked into your ASIL D application. And then when we look at deliverables here, you'll see that we offer both a development license and a reproduction license. So with the development license, you get the license to install and use the library. You get the pre-compiled C library archive files, the header files and user guide, access to the tasking issues portal, and then the safety manual in both the human readable and machine readable formats. For a reproduction license, you get the license to distribute products that incorporate all portions of the qualified C libraries, and you get the safety manual. I will provide a nice example here to basically highlight the differences between the development and a reproduction license. Before we get to the example, again, a clear distinction needs to be made between whether you're developing a product or whether you're distributing a product. The development license is for product development only and is required by all parties in the supply chain, software supply chain. The reproduction license comes with maintenance and is for distribution of a developed product without enabling further product development. So this would be required by your ECU manufacturer, for example. There are also options for a per project or a company entity license. So let's look at our licensing model example. So here at the bottom of our chart here, of our diagram, you see that we have BITA, and they are a manufacturer of ADAS sensors. And so here they make a radar sensor and they make a camera sensor, and they're currently a tier 2 supplier. We can see here Ecodyne, who's a radar module supplier, and they are also a tier 2 developer within the software supply chain. And we have Omron, who's a tier 2 of camera modules. Each one of these tier 2 suppliers, since they're actually doing development for their camera and radar modules and sensors, and they need to use the ASIL D, math functions for their application, all three of them would basically need a development license in order to use the Qualified C library. In this example here, ZF is our tier 1 supplier, and they're basically taking the ADAS sensors, the radar module, the camera module, and they are building a zone control assembly. In that zone control assembly here, you can see we're basically pairing the radar sensor with the radar module, the camera sensor with the camera module, and we're integrating it all with a RX TC4X. ZF is still doing integration work and they're doing development work, so they will also need a development license. But since they are building these zone control assembly ECUs for delivery to BMW, they also require a reproduction license. So this is a simple example showing basically the license distribution in this particular development use case. So the key takeaways here is that the software library qualification is required. Why is it required? Because library code is linked into the user's end application and it's installed on a target device, which is going in a vehicle. A defective library jeopardizes the safety case of the end application, thus the need for the qualification. If we look at the characteristics of the Qualified C library, as a quick summary here, approximately 200 functions have been certified for up to ASIL D use. It has been qualified as a safety element out of context. It is functionally safe compliant and does offer improved performance, has very easy to use documentation, offers a flexible and affordable license model, and is currently available for the TriCore version 6.3R1 and SmartCode version 10.3R1. Keep in mind that there are Qualified C libraries on the roadmap for our other compilers, which support both ARM devices and RISC-V devices. So that concludes the technical part of our presentation today. I would like to invite you to, if you're interested in participating in upcoming events, to please refer to the newly designed tasking website for more information at www.tasking.com events. We do have a couple of notable upcoming events. First of all, there is the product release webinar for the SmartCode Inspector. The inspector is a tool which provides an automated method for identifying SmartCode TriCore toolchain issues in your compiled output code. And the target date for this webinar is mid-July 25, so keep an eye out for those announcements coming soon. We're also very excited to announce the product release webinar for SWAT, which is our software trace tool. This basically is software tracing made simple. It allows you to do real-time profiling without hardware trace. And the target date for this webinar is the end of next month. Please visit ldra.com events for more information on the current LDRA sponsored events. If you're interested in any additional information or for an evaluation license of any of the tasking products, please see the contact information here on the screen. And with that, let's move on to the Q&A session here. So the first question here, it's a simple question, but a very good question. It says, does the Qualified C library only work with the tasking SmartCode compiler, or can you use another certified compiler? As I mentioned here, each the qualification of the C library and the tool set need to go hand in hand. And so we do offer qualified C libraries here for the VX tool set for Tricore version 6.3 R1 and for the SmartCode version 10.3 R1. And so, yes, it is important that you pair those together. We have a question here. How easy is it to integrate the qualified C library into an existing TC4X project? Okay, great example. So, or great question, sorry. So you're doing development, you have your RX TC4X hardware, you have SmartCode running, you're writing code, and you're writing code with the ISO C library that comes with SmartCode. So basically what you have to do is you'll purchase a qualified C license. You'll do the installation, the unpacking. There's a set of directions that basically come with the compiler, which tell you where to copy the qualified C libraries. Then you would within SmartCode, you would basically, in the add path section of the properties, you would basically point to where those libraries are. And then you would, then be able to use the qualified C library. There is a video, a how-to video that is in process, which will basically a short video, which will walk you through how to do that. And that should be available within the next month or so. Another question is I work for a tier 1 that delivers to an OEM who does additional integration. So what is again the difference between the developer and reproduction license? So the key distinction here is that if anyone in the software development chain is doing any type of development, they require a development license. If you're just doing ECU production, so if someone is selling you a module and you're just taking that module and reselling it, you don't need a develop license. You're not doing any development with the C library, but you are reproducing. So then you would need a reproduction license. Question here. Why is there a difference between the accuracy of the QM and the functional safe library? So as I mentioned in the very beginning, the QC or the QC library was implemented with a safety element out of context approach, which required a lot of additional work. So it requires, setting up the assumptions of the use case. And so it's actually the implementation of the code is physically different between what's in the QM library and what's in the QC library. And based on the algorithms that were used for that QC or qualified development, is the actual, it's more, it has higher performance, it's faster, it's a smaller footprint, requires less, ROM for storing. So that's the reason for why there's a difference in accuracy. And so I'm looking to see if there's any additional questions. Okay, so I do have a question here. Can this C library be used with another compiler? It's an interesting question. In the end, it is an ISO C library. I think that use case would have to be we'd have to examine it. Yes, it probably could be used. But again, it's not going to be recognized by your cab or by your like TÜV Nords as being certified because the library and the tool chain are not qualified together at the same time as a bundle. And we see that from the ISO 26262 requirements that that was one of the clear points that we made here is that the library and the compiler must be qualified together as a pair. And so it still wouldn't satisfy in your ISO C kind of requirements. And so I don't have any additional questions. So with that, we'll conclude our webinar for today on the Tasking SmartCode Qualified C Library. We'd like to thank you for your participation and wish you a great rest of your day. And do look forward to seeing you at our SmartCode Inspector and our SWOT product release webinars next month.